We now have our corpus prepared, consisting of the import address table of each sample. We want to construct a classifier that will read in the list of DLLs and use it to predict whether a sample is malicious or benign. As the corpus stands, it is very difficult to mathematically handle it because these are words. So what we want to do is convert these words into vectors. The simple-minded way is to count how many times each word occurs per document. So I might say kernel 32 occurs once here, but maybe here kernel 32 does not occur, so I'll say 0, and I'll create a vector out of this idea. The reason this is a simple-minded approach is that perhaps kernel 32 is what is known as a stop word. A word that is not significant but occurs very frequently. For example, the word the is very frequently occurring, but it's not very meaningful. For that reason, we use a technique called Tfidf. Tfidf stands for term frequency inverse document frequency. Term frequency refers to the number of times a word appears in a document. The IDF part stands for inverse document frequency, meaning how many documents it occurs at. If we were looking at normal text and we're classifying documents by category, the word "da" occurs in so many documents that its appearance is almost meaningless. By dividing by its document frequency, we can give its occurrence a very small weight. On the other hand, if we see a word such as Socrates, which is relatively rare, then it will be given a large weight, and presumably the document is about philosophy. So in our case, we have the same issue with things like kernel 32, which might not be meaningful, but perhaps a crypto library is indicative of ransomware, and it's rarely occurring unless we need to do some cryptography. So for that reason, it makes sense to use Tfidf. We're going to use scikit-learn. So here's the exact line to import the libraries. To use it, there is some documentation available here. Basically, you're going to take your corpus, you're going to fit your vectorizer on it so that it knows how to scale each of the words. And then you can take, let's say, the corpus, but it can also be just one vector, and you transform it with numbers representing the weights and occurrences. For instance, this is the first document, which we saw was 3D viewer. It's just 1, 0. The second document has more DLLs and they have different weights. It's not just a count 1, 1, 1, but a weight dependent on how many times each of these occurs overall. Now that we have all of our data in numerical format, our challenge has become a straightforward machine learning problem.